In terms of the Bionic Mobility $50,000 major category prize, it gives me great pleasure to announce Griffith University Professor of Bionics, Dr. Loren Frassard, and his team as the winner. Dr. Frassard's team is developing Thomax 2.0, a first ever non-invasive and easy to use diagnostic device allowing differential diagnosis of implant stability that is essential to the success of osseointegrated limbs in rehabilitation and everyday life. This innovation will help manage the stability and safety of the bionic limb and deliver further improvements in mobility and quality of life for amputees.
Thank you, gentlemen. Very well deserved. Now let's sit back and watch your entry.
Hello, I am Adjunct Professor Laurent Frassard, a bionic limb scientist based in Brisbane, Queensland, Australia. And today I'm delighted to present our project of research that will make a difference in the life of individuals suffering from limb loss who are choosing bionic solutions. Meet Rebecca, Anton, and one of our chief investigators, Caroline. They all use an osseointegrated implant. Their clinicians must make sure the bone and the implants bond strongly during rehabilitation. This triggers fear of loosening and infection. Dentists use an Osstell device providing quantitative information to diagnose implant stability. But the orthopedics industry relies heavily on qualitative evidence from medical images. Unfortunately, the rehabilitation with osseointegrated prosthesis is also guided by pain. There is a need for a medical device to diagnose stability of osseointegrated prosthesis. Clearly, bionic innovations improve significantly the life of amputees. However, implants must be removed in up to 20% of cases. This is not good enough. This is not good enough to restore safely daily mobility, let alone to perform challenging activities. I've put a service member here because I do a lot of work for the DoD. We are focusing on a well-defined group of customers, so that might raise some questions about the market size. So let's try to address these concerns. First, we will focus on a population susceptible to choose bionic solutions, with a market valued at over 5 million by 2025. Then we will expand to the global population of amputees, including 1 in 80 Americans who will be living with an amputation by 2050. This is millions of people. So this is a strategic market that is fast growing. All major providers of components are trying to find their way to enter this market. Our innovation is more likely to progress upward as a gold-mine opportunity, but more work is needed to consolidate this prediction. So what is our innovation? We want to develop a medical device called Thomax 2.0 that integrates wearable loading sensors and a personalized neuromusculoskeletal model for a real-time animation of a digital twin of the residuum during load-bearing exercises. The good news is that we have used a prototype to publish evidence of TRL5 for each part of the device. The level of user skills needed in different contexts might be an issue. However, Thomax will be a game changer. It will give practitioners a first ever non-invasive and easy to use diagnostic device to assess implant stability that is critical to the rehabilitation and the long-term success of all osseointegrated solutions. In fact, all the projects you are going to see today will be depending on this work one way or the other. Thomax will make the unknown visible, but the success of the project will be all about improving safety, mobility, and quality of life. Our team of investigators has published over 820 articles. Some of us are ranked within the top 2% of experts worldwide. The whole team includes 14 experts in the fields of amputation, artificial limbs, bone and cut prosthesis, and technology transfer. So what are we going to do during the 12 months of this project? First, we will complete the proof of concept and achieve TRL 5 for Tomax 2.0. Next, we will publish 3 articles. They won't present any patent-threatening information, but they will give us the credentials for subsequent grant applications and discussions with partners. At the same time, we will refine our commercialization pathway. This will help us to determine what will be the cost of equipment, how many units might be sold, who will be the clients, and what the reimbursement model will be. We have already identified 15 potential partners who manufacture and distribute implants, prosthetic components, or sensors. This includes 9 partners I have previously worked with as a consultant. We will primarily engage with Integrum, Össur, and Vald, based in Queensland. We will also apply for grants to develop Tomax 2.0 Plus to reach TRL 7 to TRL 9, including partnership grants. Approximately $154,000 will be required for this project. 68% will be provided as in-kind by Griffith University. We are requesting $50,000 or 32% of the budget. Thank you. This device will be a game changer because it will equip practitioners with the first ever non-invasive and easy to use diagnostic device that is critical for the rehabilitation and the long-term success of all osseointegrated solutions. This innovation will also be a game changer because it will empower end users by making their bionic integration visible to them. Simply, our innovation will make the unknown visible, but the big picture is to improve safety, mobility, and quality of life of individuals suffering from limb loss. We are very excited about this project and we are looking forward to tell you more soon. Thank you for listening to our pitch.
Amazing work, and just congratulations again. The impact you can have on osseointegration and the acceptance of the recipients is incredible. And I think if you're excited, we are too, Professor Laurent, and really wonderful to see just how far your, not the pitch, but the work has come in the time that we've been working together. Just tell us a little bit about what this support is going to mean for you and the team by way of progressing your work.
Well, I would say, first and foremost, as Laurent mentioned in both the recorded presentation and his prior comments, what we're working to do is raise the technology readiness level of the device itself. And so this investment will really help us improve the quality and the efficacy of the rehabilitation programmings using the investment directly to strengthen the components and the products.
Wonderful. And it was amazing. Please, Laurent, yes.
Yeah, no, just to elaborate on what David's doing, we will be able to capitalize on David doing his magic by doing very advanced modeling of the residuum. And that will help us to hopefully provide an experience for the people suffering from limb loss, doing rehabilitation in a far less painful way and far more efficient way. So that hopefully that will make a very important, significant difference into the rehabilitation process for people suffering from limb loss who are choosing bionic solutions.
And Laurent, I'd love to congratulate you at this point too on your professorship in bionics at the Griffith University. I do believe the work that you're doing, and as many people watching today would realise, you're doing such amazing work across the bionic limb spectrum, the spectrum of work across bionic limbs. So I think that this is a great additional project as well to that suite of work that you're doing. And for those who are watching this video, I'd urge you to look for Professor Lauren Frossard's work as well in the wider sphere of bionic limbs.
That's right. Always terribly impressed with the range of published material, and the research has gotten you to this point. But even seeing the size of the team required and the many disciplines that have to come together and succeed in order to make this a reality, it really shows the complexity that of the problem your team are grappling with, and just how impressive it is that you're making solid progress. What would be the next thing we might see from your team that would be really hitting the map? Tell us where we're going to see you pop up next, and you know, congratulate you further.
The next thing for us, the big milestone is really to develop what we call the digital twin. So it's basically the digital replica of a human that lives into the computer. It might be very complex to do that for the whole human and the whole body, but the beauty of working with people with amputation is we can actually focus the development of that model and the development of that digital twin for the specificity of the residuum. And that's complex enough as it is, but that will be a good milestone towards a bigger development. And thank you for congratulating me on the professor position. It turned out that Griffith is actually a very good place to do this type of work, because David has done a lot of work, which is why he's included in this grant, and what he will be a key person to work on the ground to develop what's called the digital twin, the digital athletes. And in many ways, what we're trying to do is to replicate that type of modeling and very complex algorithm for understanding the locomotion and the design of bionic solutions for people suffering from limb loss.
Wonderful. Well, you're a wonderful example of the sort of teams and individuals in this emerging technology set that we want to support. And you know, even in your presentation, the 15 partners, even yourself, how collaborative you are, the comments and the sharing and the team environment you foster. So thank you so much for your participation. Congratulations again on the award, and we can't wait to see what you'll do with that additional support.
Thank you, and congratulations also to Bionic Queensland, because you are going a great efforts to the rest of the community to develop this ecosystem promoting bionics at large, particularly in Queensland, but also in the rest of Australia. So we are very much looking forward to be part of that as well.
Wonderful, thank you. Congratulations again.
Thank you.